equation in slope-intercept form from, oops, can't spell, from a table. All right, so when we write an equation in slope-intercept form from a table, we need to know what slope-intercept form is. We know that slope-intercept form is y equals mx plus b. We know that the m stands for the slope, or aka rate of change. And we know that the b stands for the initial value, aka y-intercept. All right, so we know that from the previous lesson. And what we need to do is answer these questions here. So first we talk about define the independent and dependent variables. The independent variable is the x, and which one is the x? Well, x is going to be the number of mini Snickers. That means that the y is the total calories. So the total calories are dependent upon the number of mini Snickers. I can't spell mini, sorry about that. Mini Snickers one eats. The next question says, how many calories does 3 mini Snickers have? Well, if we look at the table, we can see that 3 mini Snickers has 260 calories. So 260 calories, just by looking at the table. Question number 3 says, how many calories does 1 mini Snicker have? Well, it's very difficult to tell from the table. Well, not difficult, but it's not easy to tell from the table. So we have to find the rate of change. All right, so let's go ahead and find that rate of change. Change in y or change in x. So here's our x, here's our y. We know that it changes here. So it changes in the y direction by 160 calories, and for every 4 Snickers. All right, so let's write that as our rate of change down here, or even on the side work here. We can do 106 calories over 4 Snickers. Go ahead and divide those. That gives you about 40 calories per 1 Snicker. All right, and again, that's an important information to solve this problem. So how do we find how many calories? Well, there we go. We just figured it out. 40 calories. We found the rate of change. 40 calories for 1 mini Snicker. We found it out by finding the rate of change. So, how many calories did this individual consume before eating any mini Snickers? Well, this question is asking us to find the initial value. Oops, cannot spell today. Well, can't spell any day, but value. So what's the initial value? Well, when we try to find the initial value, we want the x to equal 0. When x is 0, that will plot us on the y-axis, and that will be like our y-intercept. If we go back up to our table, well, we don't have a 0 on our table, so we have to work backwards on our table. So if we know it's 40 calories per Snicker, let's work backwards. So if I were to continue this table here, let's make a side table here. And let's start here, x and y. And I'm actually going to put the value of 3, 2, 1, and actually add in a 0 here. Sorry about that. And we know that's 260 calories. Well, if it's 40 calories per Snicker, when we go back 1 on the x, this way, we need to subtract 40. Well, 260 minus 40 is going to give you 220. So 220 calories for 2 Snickers. We subtract 1 more Snicker. That means we're going to subtract 40 calories. So minus 40 is 180. So 180 calories for 1 Snicker. And we go back 1 more time, minus 40. And that gives us 140 calories for 0 Snickers. So we must have eaten like a bag of chips or something to get 140 calories. So how many calories did this individual consume before eating any mini Snickers? Again, when x is 0, that means we ate 140 calories. Now, we're going to put all this into our final questionnaire, write the equation to represent this table. So y equals mx plus b. Go ahead and try to fill this in yourself before I write the answer down. So go ahead and pause the video. All right, filling this in, we know that y equals, m is our rate of change. We know that we have 40 calories per Snicker, so 40x, plus our initial value. We know that we consumed 140 calories before we ate any mini Snickers. So our final equation of the table is y equals 40x plus 140. Hopefully you understand that. If you didn't, go back, watch some of the parts you missed, and don't forget to ask Mr. Stauffer if you have any questions.